Okay, in this video I'm going to continue starting from question number 13 because I stopped at question number 12. So just so you won't wonder where from I have everything already solved and ready, because as you my followers know that I solve it right on the video. It just happened I was recording. I recorded and turned out about 3 questions. I recorded and turned out I didn't turn on the sound. So not to go do one work twice, so I'll just gonna go over these problems which I already solved step by step in previous video, but I will still explain step by step. And I think from starting question 16, so I will pick up there. That's where I stopped, discovered that sound is not working, and I will solve here with you. So next problem, number 13, we have f of x is equal x squared plus 5, g of x is equal x squared minus 6. So all we have to do, the composition of f with g, and then composition of g with f, and then from ready result of this composition we will plug value of 2 to find this composition for from value of 2, both of them, a composition f with g, from 2, and g with f from 2. Okay, so let's start. Composition of f with g of x, a. This is case A. What we are doing, that means in the function of f, which is x squared plus 5, let me change here color, change color, so when I underline you can see. I'll pick this one. So in x squared plus 5, I'm going to plug this g of x, which means, it's jumping around, this x minus 6, x squared minus 6, I'm going to plug in this x. Why? Because see here we have f of g of x. Okay, so I have x squared plus 5. So instead of x, I'm plugging this x squared minus 6. Okay, x squared minus 6 squared, because I have here squared, right? And plus 5. Okay, so x squared minus 6 squared, we are going to apply formula a minus b squared. Okay, that is equal a squared minus 2ab plus b squared. So my a here is x squared, which is right here, and my b is 6, which is right here. Okay, so let's see, I need a squared, first of all, a squared, which is coming here, x squared to power 2, right? And then minus 2 times ab. 2 times my a is x squared, right here, and b is 6, right here. All right? Next, plus b squared. My b is 6, which is going to be here 6 squared. And moving here this 5, okay? Because we had plus 5 at the end. So here it is, plus this 5. All right, now what we're going to do, we're going to combine these like terms, simplify. So we have x squared to power 2, it's going to be x to 4, right? And then negative 2 times x squared times 6, it's going to be 12 x squared, here 12x squared, and 6 squared, it's going to be 36, and plus 5. Okay, So the result is going to be x squared, x to power 4 minus 12x squared, and 36 plus 5 is 41. Okay? So this result is our x to 4 minus 12x squared plus 41 is a result of f, composition of f with g. Next, composition g with f. Now we're going to plug function f of x, this one, f of x, plugging into this x. Okay, let's see. So I have g of x is x squared minus 6. So I'm plugging as an x, this x squared plus 5, right? And we have squared, x squared plus 5 squared, okay? And minus 6, this is this 6 we have here. Okay? So from here we are simplifying, opening x squared plus 5 squared with the same, this formula in red color, a minus b squared. Okay? So let's see. My a is x squared. My b here is going to be 5. Instead of 6, it's going to be this time 5. So we're going to get x squared squared because of this a squared. So x squared to power 2 here. And then minus 2ab, 2 times x squared. And my b is 5 because here I have 5, right? And then minus plus 25 plus b squared, which is going to be 5 squared. Here it is. And minus this 6, moving down from the expression. So what do we get? X squared to power 2, it's going to be x to 4. 2 times x squared times 5 is going to be 10x squared. Plus 5 squared, which is going to be 25. And minus 6. So result is x to 4 plus 10x squared plus 19. And that is the composition of g with f. So we got composition f with g and then g with f. Now we need to get this composition for specific value of x. For both cases, we are taking 2, same value. So to see the difference, to show that composition of f with g and composition of g with f, it's not the same. All right. So composition f with g for value 2. All right. Where is my f with g? Right here. X to 4 minus 12x squared plus 41. So all we have to do plus the plug value 2 into this expression. So here we have 2 to power 4. There we go, x to power 4, 2 to power 4. Next, minus, we have 12x squared, right? Which is going to be here negative minus 12. 2 to power 2, instead of x squared, we put 2 squared. And plus 41. So 2 to power 4 is 16, right? Okay. Negative 12 times 2 to power 4. First, 2 to power 2 is 4. 4 times 12 is 48. There we go. And plus 41. Okay. So next, subtracting, adding. So 16 minus 48, it will be negative 32. And negative 32 plus 41, it's going to be 9. And the result is 9. So a composition of f with g for the value of 2 is 9. Let's do the same thing, composition of g with f for the value of 2. G with F for the value of 2. So, where is my G with F? You know, maybe I should have, hold on, let me make it better, so not to go forth and back. This is what I'm going to do. Move this down, and here F with G, it's x to 4 minus 12x squared plus 41. There we go. This way you can clearly see what is plugged after which one. X is 2, and plus 41, same thing. All right, let's do the same thing here before we start. Okay, composition G with F, here it is. X to power 4 plus 10 x to power 2 and then plus 19. Okay, now it will be much better for understanding. So we are plugging 2, x instead of x plugging 2, because here we have this 2, right? Okay. Okay. And result is going to get 75. How we got it? Let me go fly over real quick. 2 to power 4 is 16. 10 times 2 squared. So first we do 2 squared. It's going to be 4. 4 times 10 is 40. And plus 19. So add all together, we get 75. Question number 14. We have f of x is 16. And g of x is x over 6. Okay. I want to move all this a little bit down, so there will be space. All right. A. First, we need to find the composition F with G. So, where is my g of x? Is here x over 6. I'm plugging into this one, 6x. So it's going to be 6 times, instead of x, plugging x over 6. Okay. Let me clean this, not to make a mess. Okay. And 6 times x over 6. 6 times x over 6. 6 represents as a 1, so this way 6 and 6 is gone, and we get x result, yes? Okay, so we get x here. Next, composition B, composition G with F. So which means we are plugging f of x into G. Where is my f of x? Is 6x here. Plugging into this x. There we go. Instead of x, I'm plugging 6x. Here it is. And divided by 6. There we go. So again, 6 and 6 canceling, we get again x. So what does that mean? Here I have x. Here I have x. So when composition of both of them is equal x, that means these two functions are inverse to each other. That's what it is. This is what we did. We checked if these two functions, f of x and g of x, if they are inversed. So we got the same value, x, that means they are inverse to each other. Just like with graphing inverse, right? Switching x with x and y, we switch, we get inverse. Now here we are checking if they are inverse or not. Question number 15, the same way we are going to check if it's inverse. Let me move a little bit this range better way. 1 second, give me 1 second. All right, and this. I will move down here. Continuation. Okay. Okay. So so we need to again find out if these two functions are inverse or not. To find out if two functions are inverse, all we have to do, take the composition f of g, f with g, and then g with f. And if we get the same value, same result, then these two functions are inverse. Okay, so first one, composition f with g, which means value of g, x plus 3, this one, x plus 3, I'm plugging into the whole this expression, I'm plugging into this x. So here it is, 3 times, instead of x, plugging x plus 3 over 2 and minus these 2. Okay, so let's do it. To multiply, 3 are represented as a 3 over 1, so 3 will go to numerator, 3 times x plus 1, 3, all right, and over 2, and minus these 2. So what did I do here? I have to bring to common denominator. So since denominator is 2, with red color here I plug 2 because denominator is 2, and for these 2 that I have here, denominator is 1, right? 2 over 1. Therefore, to bring to common denominator, I have to divide, put denominator 2, but whatever change I do to denominator, I have to do precisely same change to numerator. Okay? That's why I divide by 2 and multiply by 2. And as a result, I got, so I distributed 3 by x plus 3. I got here 3x plus 9 and minus 4. It's coming, this minus 4 is coming from here. Minus 4. And I combined these two the fractions because I have denominator the same, 2. And as a result, we'll get 3x plus 5 over 2. All right. So this is the composition of f with g. Now let's do composition g with f. Okay, which means in this case I'm going to plug value of f of x, this one. What did I just, okay, the value of this 3x minus 2, I'm going to plug into this x backwards. So instead of x, I have 3x minus 2. Where did this jump? What just happened? Sorry about that. Well, that's a technology. We all know that technology can go crazy without asking permission. Okay, here we are. So 3x minus 2, this is this 3x minus 2, we plug instead of this x, and plus this 3 and divide by 2. Here, plus 3, divide by 2. And result is 3x plus 1 over 2. Now, what did we get? In this case, we got 3x plus 1 over 2. Here, we got 3x plus 5 over 2. Are they same? No. Which means 3x, if the 3x minus 2 and x plus 3 over 2 are not inverses, okay, to each other. All right. Moving to question number 16. We will check this one also on inverse. And then after that, we will move, instead of checking if these two functions are inverse, but we will be given only one problem, and we need to find what will be the inverse of that. Okay, so question number 16. Starting from here, I'm going to solve, because that's where I figured out there's no sound. All right, so we need to do first a composition f with g of x. And it's getting more interesting because this is getting nasty fraction 4 over x plus 6 and here 4 over x minus 6, right? So that means I'm getting g of x as a parameter for f, which means this entire 4x plus 6 I am going, let me see, 4x plus 6 I am plugging into this x. Look what we are getting, nasty problem. Okay, all right, let's start working. Let me write down. We have 4. Now instead of x, I'm plugging 4 over x plus 6 and then minus 6. Right? All right. So first of all, I'm going to simplify 4 over x plus 6 minus 6, and we'll see. If I have plus 6 and then minus 6, what we can do? This plus 6 and minus 6 we can cancel, right? Okay. And what do we get here? 4 divided by 4 over x. Yes? Which is going to be equal 4 times x over 4. So division, it's we are flipping the second fraction. You do not dare to flip the first fraction. It will take you straight to the wood. Okay? And result is going to be practically, this 4 will be cancelled with 4, because if I represent as 4 over 1, then I can multiply just like that, and the answer is going to be x. All right, here we got x. Okay, now we need to find b, we need to find composition g with f. So it's going to be g of f of x. Let's see. Now we are going to go opposite. Now I'm going to take this 4x minus 6 and plug to this x. Okay? So it's going to be 4. Instead of x, I'm plugging 4 over x minus 6. And here plus 6. Okay, so first I need to take care of this. Let me see. I need to take care of this fraction, right? Let's simplify. So it's going to be 4 divided by 4 over x minus 6, which means 4 over 1 divide by 4 over x minus 6 and plus 6. This is equal 4 over 1 times x minus 6 over 4 plus 6, because we have division, so we are flipping the fraction, and instead of second fraction, which is 4 over x minus 6, and you will get x minus 6 over 4. Canceling 4 and 4, and we are getting x minus 6 plus 6, canceling, and we are getting x. What did we get? Composition g with f is x, composition f with g is x. And from here, we draw conclusion that the functions f of x and g of x are inverse. All right. Now we are moving to the cases where both functions are not given only one function, yeah, and I need to find the inverse. Okay, I need to find the inverse. So that is question number 17. We have f of x equal 8x plus 4. We need to find inverse. Now, one thing I need to tell you, just so you know, inverse function can have function that is one to one function, okay, which is 1 to 1 in this case, because for every x is equal to every x we have 1y. Okay, so let's start working. How are we gonna find out? I'm going to replace, so f of x is the same thing as a y, so y is equal 8x plus 4. To find inverse, all I'm going to do, replace x with y, which is, I'm going to do here x equal 8 and replacing here y plus 4. That's what I did. And from here I'm going to find my y. So 8y is equal x minus 4, because I'm moving here, it was positive, will become negative. And to find y, I'm going to divide by, x minus 4. And to find y, I'm going to divide by 8, right? Because I need y, not 8y. This 8 and 8 is gone, and as a result I get y is equal, since denominator both of them are 8, I can write down 8, and on the top x minus 4. Now, that this y that is equal, let me see, this y, y is equal x minus 4 equal 8. This is inverse for original this expression function 8x plus y, 8x plus 4. And inverse we mark down as 8 f of negative 1 of x. That is inverse. Okay? Question number 18. Question number 18. We are given f of x is equal 7x plus 9 over x minus 1. And obviously we have to put condition x cannot be equal 1. All right, let's start solving. So first of all, I'm going to replace x with y. So first of all, I'm writing down, because f of x is same y, is equal 7x plus 9, and here x minus 1, right? Okay. So then I'm going to replace, it's going to be, instead of y, I'm getting x and then 7 plus 9 here minus 1, and plug here y, and plug here y. Okay, so what we are going to do, we are going to solve for y here. See how much my y will get. All right. So to find y, we need to bring to common denominator because we have equation, right? So the only denominator we have is y minus 1, which means this x also we have to multiply and divide by y minus 1. That's exactly what I will do. Here I put y minus 1. On the top also y minus 1. So do I have y minus 1, y minus 1 on both fractions? Yes, so I'm dropping this denominator, and result is going to be x times y minus 1 is equal 7y plus 9. And I'm solving for y, don't forget that. Okay. So we multiply xy minus x is equal 7y plus 9. Now, since we need to find y, so I need to move the 7y where this xy is, and result will be, once I move, it was positive 7y will become negative 7y, xy minus 7y equal, this negative x I move will become positive x plus 9. Okay, taking y as a common factor out, I will have x minus 7 equal x plus 9. And to get y, I have to divide here by x minus 7. And accordingly, same thing I'm going to do here. So x minus 7 here is equal y. And y is equal x plus 9 over x minus 7. So for this is going to be our inverse, right? There we go. This is going to be our inverse. Now, what is interesting here? That we have division on x minus 7. Here we have to put x cannot be equal 7, because at the minute x is equal 7, we are getting division by 0. So we have two conditions that are going to be satisfied. Where is it? Number 8 is this one first. X cannot be equal 1, and we came to x cannot be equal 7 also. All right. Okay. Moving to question number 19. What do we have here? We have f of x is equal 4x minus 9. All right. So 4x minus 9 is given function. We need to find a. We need to find inverse f to negative 1. B. We need to graph f, and we need to graph f to negative 1. So direct function and inverse function in the same rectangular coordinate system. And C, we need to use interval notation to give the domain and range for both f and f to negative 1 inverse also, which means we're going to find domain and range. Okay, let's start. A. First, we need to find our inverse. To find inverse, I'm going to replace, right? F of negative 1. So let's see how much we're going to get. F of x is equal 4x minus 9. And that is y. Same thing. Now, I'm going to flip the sign. I'm going to get, x and y, I'm going to get x is equal 4y minus 9. So from here, 4y is equal x plus 9, because I'm moving here, and negative 9 become positive 9. And once I divide by 4, because I need y by itself, right? And this is canceling. So my inverse, it's going to be y is equal x plus 9 over 4. And which is, we write down f2 negative 1 of x. Okay. That is question number 1. Next, B. We need to graph on our original problem and inverse problem. So let's see. Let's start. First one is 4x minus 9, original one, right? Which means we are going to graph, let me bring this down, our f of x is 4x minus 9, and our f of, let me put different color, negative 1, which is inverse, is equal x plus 9 over 4. Okay, let's build it. So this is 1. Okay. So not to make the coordinate system too big, let's assume, so forgive me, I'm going to assume 4x minus 9. Minus 9, it's going to be here, minus 9. And my 4x, let me see, if my x is 1, 4x, it's going to be here. How to graph it so it make it easy for you? Let me see. Give me 1 second. Let me figure it out. How to make it easy. Okay, I can go by slope intercept. Let me go with slope and intercept. Then I have to graph here. I have to keep the proportion 1, 2, 3, 4, 5, 6, 7, 8, 9. Here it is. So this is our 9, negative 9, right? Next, I'm going up by 4 because my slope is 4, right? When we have slope 4, meaning 4 over 1. So I'm going up by 4. 1, 2, 3, 4. This should be negative 5 because negative 9 plus 4 is negative 5. And moving by 1 to positive. Negative 9 up by 4. So it's going to be, this is 1, and this point, the graph is going to look like this. Okay, so this is f of x. Now we need to go through inverse f of -1. So let me rewrite it. Since it's linear equation, I'm going to rewrite x over 4 plus 9 over 4. Can I do that? Of course. And x over 4 is 1/4 of x plus 9 over 4. Correct? And I go by slope intercept again. Yes? Okay. So let's see. I'm starting with 9 over 4. 9 by 4, it's going to be 2.5. So it's going to be somewhere 2.5 here. 1, 2, 1, 2, 2.5, somewhere here. 2.5. And then go up, my slope is 1, so I'm going up by 1 from here. And then by 4. So 1, 2, 3, 4. Okay, so this point and this point. This is 2.5, 9 over 4, this one. Okay, and this is 4. No. Yeah, 4, that's right. Okay, now let's provide the graph. Okay. So, and this is going to be inverse. So, inverse of this graph. How can we check it? Inverse on the graph. We switch x with y. Let's take it. Let's see. This point. No, let's take which point we take. Let's take this point. Let me change the color so we can take different points. This is 1 and 2. Well, you understand it can be a little bit slightly different because I'm not doing exactly on the graphing paper. So this is going to be 1, 2, 3. So coordinate of this one is 2 and -3. What a horrible color. So 2, -3. Right? So, okay. On the if I look at the inverse graph, so I should get -3 and 2. Let's go. 1, 2, 3, -3. 2 we have here. So this is going to be, let me take this one. This point is going to be at the, so if the inverse is, and if I go perpendicular to this graph, I will hit this point. I need to take black one, or so we can see this. color. See? So we got we got the inverse point here. All right, so if I take this point is on y, so the inverse, if I go perpendicular, is going to be point on x, right here. And it's this arrow, you see it's heading to that point, right? Okay, and that's how you find out on the graph. Switch, which means if here I have the point 0, -9, this point is going to be -9 and 0. So if I take this point, let me see, if I take this point, what is this point? -3, 4, this is -5, and this is going to be 1. So inverse is going to be 1 and -5. Here is 1. 1, 2, 3, 4, 5, -5. So if I come down, well, somewhere this one is going to be inverse. This is going to be 1 and -5, see? Okay, that's what is inverse. All right, said that. Now let's go over domain. What is going to be our domain? So for f of x, domain is going to be -infinity to +infinity, and the same way range is going to be +infinity, -infinity, right? Okay, let me write down. For f of x, because we have linear equation line and we don't have any interruption, correct? So for f of x, domain is -infinity, +infinity, range is -infinity, +infinity. Same way for f of -1, which is our inverse. Let me use this color since I am using inverse with this color. It's going to be the same, right? Domain, there is no interruption. It's running from -infinity to +infinity. All right. So I'm going to do one more. Last question, question number 20. Let's do it. What do we have in this case? Square root x minus 7. Question number 20. That is going to be my last question. Given function f of x is equal square root x minus 7. A, we need to find f of -1 of x. Okay. So f of x is equal y is equal square root x minus 7. So now I'm going to exchange. It's going to be x, and then here let me put y, and the rest it's going to be square root y minus 7. So we need to find y from here. So every time when we have equation with radicals or square root, we have to get rid of that radical or square root. How? We're going to square it. If it's square root, then we square. If it's radical degree 3, then we put to power 3. If it's radical degree 4, then we put to power 4. So here we have square root only, which means I'm going to raise to power 2. X to power 2, and entire thing to power 2. The result is x squared is equal y minus 7. Okay? All right, y minus 7. When we have y minus 7. We need to find y from here, right? Okay. And we are going to get y is equal x squared plus 7. Correct? So we can say that inverse f to negative 1 of x is x squared plus 7. There we go, x squared plus 7. Okay, question number B. We need to graph f of x and inverse of f of x. So we need to graph f of x, which is equal square root x minus 7. I could write down y, it's easier to, because on the graph we're going to put y. And let's do both, okay. F of x equal y. And inverse f negative 1 of x equal y equal x squared plus 7. Okay, let's build a graph. So first one, x minus 7. So from the minus 7 is a change of x, as you can see, because it's with x under the square root. So change of x always goes towards opposite direction. If you want to know why, you please go watch the graphing function, or I'm going to place the new video about graphing quadratic equations. Because real quick to remind you, if I put square root x minus 7 equals 0, that means x minus 7 also equals 0, and x is equal 7. That's why. See? It's equal positive 7. So if it has x minus 7, then we shift by positive. If it would be positive 7 here, then we would end up with negative 7. All right? For that basic reason. So x always changing to the opposite direction going. So if it's negative 7, we need to count 1, 2, 3, 4, 5, 6, 7. Here is 7. And the graph for square root x minus 7 looks like this. Okay? Now we need to draw the graph inverse. So to make it easy to graph inverse, let me see. Oh. Okay, one more time. Graphing inverse. So this is going to be my line that's going to be symmetric, the inverse functions. So positive 7, the graph is going to go like this. And inverse x squared plus 7, we know x squared goes like that, right? So if this is my x squared plus 7 is a change of y, it's not with x. Because if it would be a change of x, we would have x plus 7 squared. See? x plus 7 squared is a change of x, but x squared plus 7, that's a change of y. So which means change of y, we take it, the parabola, and move up by 7, okay? Therefore, where is my x squared? So approximately it's going to be like this. And move by 7. Let's say this is my 1, 2, 3, 4, 5, 6, 7. Okay. So it's going to go like this. So practically it's going to be inverse. Now this piece, it shouldn't exist, only we have to have this piece, because we are taking inverse of this one, of this blue color. And if I provide line, I will get inverse point on that one. There we go. All right. So let me clean this. That was just to help to build. And this point is 7. Look, here we have coordinate 7 and 0. Here we have coordinate 0, 7. So any point you take, let's say if I continue here, 7, 8, 9, 10, 11, and this one is what? 1, 2, 3. Let's say 11, this point. It's 11 here, so it's going to be 11 and 3, which means if I go up, it's going to be 3 and 11. This is 7. Let's see. 8, 9, 10, 11. Well, I didn't keep proportion. This is 11 and this is 3. So if I go up, there we go. This point is going to be inverse. This is going to be 3, 11. It's going to be inverse for this one. See? Okay. So the last thing we need to do is domain. We need to find the domain for f of x and inverse of f of x. Domain and range. For f of x, let's go back to our original, what was that? Square root x minus 7, yes? So is there restriction? You bet it's restriction, because look here, it doesn't go beyond, it's starting from 7 and here. There is no function or anything. It cannot be less than 7, right? The restriction is we cannot have negative number under square root. Right? It can be under square root, can be either 0 or greater than 0, entire expression under square root. So let's put this condition. Square root x minus 7 has to be greater equal 0. Okay, let's find what's the value of x going to be. So squaring here. So it's going to be x minus 7 greater equals 0, and from here x greater equal 7. So in my case, x has to be greater equal 7, which is on the line. This is solid because it's included. Goes this way. Or there is other way also to mark down the square brackets going towards infinity. And that is 7. All right? So the domain for square root x minus 7 is going to be square brackets 7 infinity. Now let's look range. Okay, for the range, where is my y here? Range is y, right? It's right, starting from here, it's 0. And then as this arrow going to infinity, it's my range is going to infinity also. So it will start from 0, right? And goes to infinity. Okay. Now let's find out domain and range for the inverse function. F of negative 1 is equal, what did we have? X squared plus 7. Well, that's x squared plus 7 is easier because what do we have? This is our graph, and x squared we have. So what is going to be a condition? It's going to be from 0, right? My value of x starts from 0, correct? Let me put this blue color so you will see. Start from 0, and since the graph is going to infinity, that means x also going to go to infinity. At this point, domain is going to be 0, infinity. Actually, it should be square bracket because 0 also included. And okay, range is also, let me fix it, it's a square bracket. Sorry, just a human, I'm also a human. Believe or not. Okay, and the range, how much is going to be range, which is y? If you look here, it starts from what? Starts from 7, yes, and goes to infinity. And it is going to be 7 to infinity. Okay, I'm done. I will put at the end of the screen, I will put the reference to the video. Which video was that? Yeah, rational simplification of rational expressions. I will put there so you can watch it, okay? Well, in the meanwhile, thank you for watching. If you like it, if you like the way I am representing a solution of problems, please put likes so I can know. Or if there is any topic you are struggling, having trouble, you can put in the comment and I'll make sure I'll create video for that. Okay? Okay, dokie. See you again.